Hey everyone, happy B-Sides. I am Matt Bosack and I am here today to talk to you about Kettle of Fish in a Barrel. So this is a little bit about the journey that we've been on at Comcast Xfinity with our bug bounty program, and one of the approaches that we've come up with about a problem that we have seen come up frequently around subdomain vulnerabilities and takeovers. So I've worked at Comcast since 2018, and I joined an in-flight team that was working to operationalize a bug bounty program to go public and to accept vulnerabilities and then begin the process of working with the research community to reward their findings and their work for that. So I'm a senior product security engineer there, still on the bug bounty team. It's our PSIRT, the Product Security Incident Response Team. And before that, I earned some engineering degrees at Temple University with a focus on control systems. I was there for quite a long time and loved it there. And then got into some other security spaces, actually focused on machinery control systems and industrial control system security. So that's how I kind of broke into the security space in general before going and joining Comcast, and have been there on the bug bounty team and love that as well. So excited to kind of bring some of the things that we've been working on in that area or with them. So got through the boring stuff. This is a little bit of an overview of where we're going to be going today. I'll dive a little bit more into Comcast and the bug bounty program we have there and what leads us into subdomain takeovers. This isn't a new problem, and I'll talk a little bit about that, but it's something that we've seen pretty frequently. And so I'll give a little bit of a background on that, some of the first researchers to find it, and then a little bit of the technicalities of what they are. Once we cover that, we'll be able to talk about what our solution approach was, how we went about implementing it, and then some of the findings and the future work that came out of it. So it's really that approach that is kind of the exciting part about it, combined with a little bit of the bug bounty program and thinking in perspectives about this that hopefully you might be able to think about this in a different way also. So Comcast, from an outside perspective, I think is usually thought of as an internet and TV company, which is fair. I think more accurately, and they'll probably say it's a technology and a media company. So it is internet, it is TV. There's NBC and Sky. There's business enterprise aspects to it also. But when you actually get inside, and this was also kind of surprising and cool for me to see also, it's a full up engineering and innovation shop. So, everything that, a lot of the technologies that you cover in engineering, networking, programming, front-end development, back-end development, cloud, security, hardware, networking, if I didn't say that. So it covers a huge gambit of technologies, and there's a lot of really great engineers working to kind of bring these things forward for the company. And so, as you might imagine, across all of those areas, and with as big as the company is, I think to this community, what that probably translates to is a really big attack surface. And that's also true. And so one of the goals of having the bug bounty program is that, as security's kind of exploded in the last 10 years, and bug bounty has kind of exploded in the last 5 years or handful of years or so as well, people are looking at this stuff. They're not going to stop looking at this stuff. And we provide a front door for them to be able to find that if they do come across something in their work and in their research, they know where to go to be able to get it into the proper hands to come to a resolution. A lot of the people that are working in security now do it for the betterment of the community and society. So it offers that opportunity to do that. So we also work with a company called BugCrowd. They're our vendor for doing this. And they offer a great intermediary service for us where it's not just an enterprise versus an individual, or individual versus an enterprise, or working together, or they said, or anything like that. They are a really good advocate intermediary for everyone involved, and you can kind of submit through there. They'll also do some triage assistance for us, and we get to work with their engineers and then also interface with the research community through all of the bug bounty programs. There's obviously other bounty service providers out there, HackerOne, Synac, and they also offer kind of a augmentation to a security force, especially when you have a really large company or you're working in an area that really has nothing to do with security and you don't have security expertise in-house that you can go out and kind of work with these companies and then have the crowd help you out. So it's a really cool space to work in. We do have 2 public-facing programs right now that you can find through BugCrowd. I think you just go and search for us either through Comcast or Xfinity. Both of them will pop up. We have the Comcast Vulnerability Disclosure Program, which really kind of catches everything under the Comcast Xfinity umbrella. And then there's also a specific subset of the bounty through or with our Xfinity home automation products. So both of those are paying cash bounties right now. So you can go and do work, and if it ends up being validated, you can earn some extra money for some Red Bulls or something. So with this program being launched in 2018, we have had an opportunity to kind of see some trends come across. A lot of the things that we do see are OWASP top 10 type things. But we've also come to realize that subdomain takeovers has been a pretty frequent submission that we've seen throughout our time. So a little bit of background on that. I'll cover what I think I see as like the genesis of this, of where this kind of originally hit mainstream. The 2 big ones that we deal with a lot are Cname takeovers and Dangling name servers. And talk about some of the caveats with those. And then I kind of talked a little bit about the frequency leading into this, but we'll cover these things as we move forward. So these 2 researchers on the left is a HackerOne submission from Franz Rosen. And I actually think that he was working for Detectify at the time when he wrote this blog. And there's a really good talk from him in 2015 that covers a lot of the nuts and bolts of subdomain takeovers. He was one of the first to come across this problem of when your DNS records kind of go out of maintenance or go stale in some way, someone else can claim it and set up a malicious service behind that. So you can see on this ticket, he actually ended up earning $1,680 for this one, which isn't bad, especially when you see the relatively, I think, low effort that goes into finding it. Low effort might not be the best way to describe it, but I think it's once you get things operational, it's a low technical effort when you see what's going on. So he was one of the first. So by no means is this any kind of new problem that we're presenting on here, but this is just another approach of a way that you can go and kind of look at this problem. So the one on the right is Patrick Hudak, and he actually has a really fantastic blog that if you're into this, I would go check out. Kind of does descriptions and playbooks for every type of subdomain takeover. And when he found this one on Starbucks in 2018, I think this is when it kind of hit prominence, and the bounty community at least really started to go after this and try to sink some teeth into this. And it really paid out, I think, in the long run. So interesting perspective on just kind of bounty hunters in general. There's many different ways to do it, and at least 2 types of bounty hunters that we see are, you can kind of look for everything, do all types of scans, go after every type of vulnerability, every type of business, and just kind of do a heap spray and find vulnerabilities and file reports that way. Or you can also do farming. So I feel like OX Patrick is one of the bounty hunters that's really good at farming. He set up some really nice tooling around his process to the point where I think he's even doing API calls to write his reports for him and submit them into bounty programs. And so it's really just a cash operation at that point, which is pretty cool. So that's a little bit of the background of where it came from. The Cname takeovers, or the canonical names in the DNS system, are really aliases or symbolic names. So the example that's on here is there's a pretty slick service called surge.sh, which does static deployment for front-end websites. And when you go and you register at Surge, it'll give you kind of this random domain name. This one here is betterattackarmy.surge.sh. So that's fine and good, unless it really has nothing to do with the product that you're trying to promote or work on. And so you can go and you can buy a domain, or you can register a domain, have a domain like we do at Comcast, and then you can set up the CNAME record to point to that Surge domain that it was given to you. So now when I navigate to that more appropriate alias, it'll still pull the A record and send me to where that service is being hosted. So in the middle there, when you first go to a surge.sh domain name, there's nothing there. So it's project not found. And then if you dive into the source a little bit there, you'll see that for for basically every service that you can go and register for, if something's not there, it'll give you kind of this 404 type of message. And each one looks very different. So you can go and actually identify a fingerprint or a signature of what this looks like. And that'll become useful later. So what ends up happening is I register a name, I use the CNAME to point to my service, and then I deploy a site behind it, and then it works, and it's very cool. The problem lies in when I'm finished, or I pack up and I move elsewhere, or I'm just done with this domain. I will delete my Surge account, but I'll never actually clean up my DNS records. So if I discovered this, I can go and navigate back to betterattackarmy.surge.sh, realize that nothing is there, and then I can go and register this account on Surge, and then basically set up anything I want as the website behind this. So the problem is that at that point, you can abuse the trust, in this case, of the Comcast.com domain name, and set up anything you want there. So that's the CNAME type. The other type, which I think is the more nefarious type here, are dangling name servers, or NS records. So right under that title there, you'll kind of see if you do a dig of this domain, it'll come back as a serve fail. So what this means is the DNS system can't fulfill your request because it actually doesn't have any information about the thing that you're looking for. In this case, on the bottom right part of the screen, if you go and you dig the Comcast DNS servers, this is saying that all of the name server records for this particular domain have been delegated to AWS. And then when the kind of public domain servers go to AWS and ask for information about this domain, it doesn't have anything. And so what this means is that these particular name servers that it's asking are no longer the actual name servers that maintain the records for this. An interesting thing about Route 53 is that you can go there and you can register any domain name for anything in the world. The difference being that's fine, because as long as you maintain the records for them, the name servers will never point to your registration of that. It'll only go to where the system of authority says to check with the name servers. So the discrepancy that happens here is that in the top right of the screen, there's this is the record set from Vinyl DNS. So at Comcast, we recently migrated all of our DNS records into Vinyl, which is open source and very cool and very useful. It has been kind of a great service for us. And then in that Vinyl system, I'll let the Vinyl DNS know that these are the name servers that I want to use. And then so I'll register my domain in Route 53, bring that information back to Vinyl, register it, and then it's good to go. The problem that occurs here is just like with the CNAME, if I go and I delete this, or if it gets deployed or redeployed in some way, and these name servers get overwritten, and I don't update the records in Vinyl, now I have that discrepancy that someone else can go and register it. So some of the things that you can do with that, why it can be more nefarious, is at that point you have full control over that subdomain. You can create new subdomains under that and kind of spawn out into a whole other different set of problems. You can set up MX records and mail servers and then send emails from the domain that you have kind of taken control of. This is one instance of the CVE for this type of problem. And CVSS version 3, if you're into that type of thing, is a medium. There still kind of requires some human interaction to go and get people to navigate to these things. And if it's a really wonky subdomain, then it might be obvious that something's going on. But nonetheless, there are non-wonky subdomains that you can take over and do a lot of harm if you're not maintaining your records properly. So after we got all of these submissions coming in, we said, all right, well, maybe this is something that we can be a little bit more proactive about. And so we started to make the researcher automated framework for information, knowledge, and insight, or Rafiki. And it was really kind of based off this idea of being the researcher, kind of seeing what they were doing, and then picking up on their trends, and then going out and searching for things on our own, kind of trying to morph it into a little bit of a framework to get other trends built into it. But the primary focus now is for subdomain takeovers. And as we talked about a little bit, it's really been influenced by the large and dynamic, ever-changing perimeter that Comcast has with all of these DNS records. One of the cool things that's really promoted at Comcast is kind of innovation and rapid innovation. And so we allow a lot of teams to maintain their own records. It would be kind of haphazard to funnel all that through one place anyway. So there's a little bit of anarchy to it, and this has brought light onto that, and we're working to address it, both from our team, the security perspective, and from the development side of things. So with Rafiki, originally, what we did was we glued a whole bunch of tools together. So there's a great list of things on the right-hand side that we basically wrote a bash script around to go out. We fed it domains on Comcast and on Xfinity, and went through Sublister, DNS Recon, and Amass, and just aggregated tens of thousands of records of all these domains that we wanted to look at. And then at that point, we fed it through Subjack, which was really fingerprinting in the same way that we talked about earlier, to go out and look for Cname types of takeovers. There's another cool repo from EdOverflow called Can I Take Over XYZ that maintains a really good list of the types of services that are examples of this, where you register for something, you're given a domain name for it, and then you can set up a Cname record, and then it becomes kind of this race condition. If you delete your account, someone else can register it, and you have to maintain your records. So this was the first iteration. It was in Bash. There's a very brief period of time that we put it in a Metasploit module, but we actually don't really use Metasploit on our team. So it didn't make sense. And it was still very manual. It was still me running this on my computer daily. So we wanted to just kind of offload it into the cloud. And Amazon provided a great place for us to go and do that with this kind of architecture that we built it around. So an engineer in our team went and built Amass into a container. And then we just got the authoritative records from Vinyl and aggregated all of those together, and then pushed them up into an S3 bucket. So it sits there and gets batch processed by a Lambda. So it's put into a CSV and sits in the S3, and then is run over from a Lambda, and then just brought into a Dynamo, and sits there until it sets off a trigger, or some of these run on time delay scans. And then each one of these will serve a different function, looking for these subdomain takeovers. So we have a Lambda that does that reads from the database, goes and does Cname scanning. We have a separate Lambda that does scanning for the Dangling NS records. And then there's also a module that we have in a Lambda that will go and then register and delete and re-register your name that you're looking at until it actually pops and grabs one of these Amazon name servers. So there's a finite amount, maybe 2,500. So, eventually, if one of those records is available, you can go and register it. And then at that point, you own that domain as well. If any of these come up as a positive and there's some sort of match, then we have it set up to email our team And at that point, it's kind of, it is back to manual at that point of going and verifying that this issue actually exists. So for the Cname scanning Lambda, and if you haven't checked out Lambdas, they're super cool. Serverless way to do computing off of, in the cloud, but off of your computer. Supports Python, Ruby, Go, Node, and then you can actually set up your own engines if you want to use some other language. I think Java's in there too. But so we're using Python. And so it pulls everything down from the Dynamo. We're using the Python requests library, and we'll check the Cname, and then we'll actually do a get on the Cname. And that's where kind of those fingerprints come in. We'll use @overflow's database and kind of just have that file that's in the bottom right of that unique signature in there, and we'll parse over the get request. And if there's any kind of match in here, then we know that that service is no longer being used, and there's a potential for a takeover happening here. So at that point, we'll send out the notification and kind of just loop over it. I think right now, the mass scan for all the different types of domains that we're pulling down is actually in the tens of thousands. I'm going to say like 65,000 records. So it's going and then scanning all of those for these fingerprints if it can pull something down. For the Lambdas that we have for the Dangling NS, again, goes and pulls things from the Dynamo. And then we'll actually just kind of do the dig against it using Python DNS and then check for that serve fail. If there is a serve fail, it indicates a potential vulnerability, and we can send it to Brute 53, which will then do that register, delete, re-register until it actually gets a match. There's another way that's on here that we're working on. We obviously have access into all of our AWS accounts. So we can get kind of those sources of truth of what's in Route 53 and what's in our vinyl and do a comparison against that. One of the gaps that's there is, with delegating those records into AWS, it points to that one subdomain, but then teams can spin up other numerous subdomains under that, which we might not necessarily have the source of truth for. So this works really well for something in that regards. At the end of the day, Riki, the researcher automated framework for information, knowledge, and insight, has been operational for on and off for a year. And we have 54 actionable findings. And since we've been tracking this in our bug bounty program, we've had 86 actionable findings, I think, since late 2018. So 2 years. You can kind of go back and look at some of the other bounty payments, extrapolate what that may or may not equal out to. It'll be close. But we're catching up. We're still looking. We're adding a lot of domains back in, and that's one of the other cool things about the bounty program is that people are so creative, and they always come up with awesome ways of approaching things or thinking about things in new ways that you see it come in, and I get yelled at that we didn't find it, but then it's a cool opportunity to kind of tweak and adjust. Running all of this in Dynamo and in the Lambdas and the S3s is pretty cheap. If you found one high impact domain, it would pay for your costs and a bunch of cases of Red Bull or whatever. So all in all, it's been successful. We're looking to expand on it, and it's been kind of a joy to work on it also. And it also represents kind of an evolution in our security posture in-house, in that we weren't really aware of this problem until we realized the frequency that it was getting submitted, and then started doing our own scanning and kind of had that, whoa, yeah, all right, this is a problem. So it changed the way we do things on our side. And then now, because we're improving our security and because we're also improving the way that we're hunting things, it also makes the security researchers and the bounty hunters kind of change and morph in what they're doing too. So not to be like over philosophical about it, but it is kind of symbiotic and a back and forth. I guess it's more of a chess match, but a very respectful chess match with your friends. that's really great. So those are the results. Where we're going is, there's always new domains that we're realizing that we use on APIs or other backend systems. So kind of expand our hunt for those. Continuing to update and modify the fingerprints that we have for Cnames. Pull more sources of information. So we're using Vinyl, and we're looking at the Route 53 stuff, but this isn't a problem that's specific to Amazon. So where else can we get data from to inform our process in doing this? We have support to do this. It's not in a place to do it yet. I don't want to be that guy that says we're going to publish the code and not do it. So this is a huge goal of mine. Hopefully we can share this with the community in the very near future. So that's all I got. Thank you, everyone. I hope that this was somewhat entertaining and useful. Thanks to the peeps at Comcast for supporting me to do both the work and the talk. Thank you to BSides, and thanks to the community. See ya.